everyone, and welcome to the SSPI podcast by Space and Satellite Professionals International. I'm Tamara Bond-Williams, Executive Director of SSPI. This episode of the SSPI podcast is part of our Better Satellite World track of conversations, exploring how our industry is making a difference in the world. Today, we continue the series Accelerate Change, sponsored by SES. It's exploring how creative collaboration is transforming the pace of innovation across the space and satellite industry. In today's episode, Digital Speed, Cloud Native Operations, and the New Space Architecture, we'll take a look at how cloud infrastructure is reshaping the way we operate in space. Mission management, ground systems, and even satellite software are becoming cloud native, more agile, responsive, and scalable than ever before. To help us understand this shift, we're joined by three leaders from Amazon Web Services: Shane Hawthorne, AWS Principal Space Advisor. Shane brings decades of experience in military space operations, space control, and technical leadership, including his prior work at MITRE. At AWS, he founded AWS Ground Station and now serves as Principal Space Advisor. Jonathan Fraker, U.S. Space Force Account Executive, specializes in cloud-enabled space operations. He previously led cloud-based mission management systems at Raytheon Technologies. And Akanksha Alok, Solutions Architect for Artificial Intelligence and Machine Learning. Akanksha has built end-to-end machine learning systems at AWS and now helps organizations design and scale intelligent applications for both ground and space, including generative AI, agentic workflows, and large-scale model inference. And to all of you, welcome.
Thank you for having us, Tamara.
Well, listen, I'm just going to jump right in. We've got three folks here on the call, and I'm excited to talk to all of you. I'm going to start with Shane. So just giving us a big picture overview, you've worked across military space, national security, and commercial innovation. What has cloud changed about how we think about operating in space?
Well, it's always a fun question to answer, Tamara. I've been doing space for a long time, so I can remember in the old days when we would really focus on building exquisite spacecraft that would just, last forever and do their mission perfectly. But that really always came as a big cost. It was expensive. It took a long time, and it could oftentimes make it much more difficult than maybe it needed to be. Mm-hmm. First off, the cloud has really enabled a lot of smaller, more startup-oriented companies with incredible ideas to flourish by lowering the barrier of entry to getting into the space industry. And it kind of goes back to, if you look at how Amazon itself was started by Jeff Bezos and the team, they really were able to start Amazon relatively easily because it was able to build on the foundation of the Postal Service, Federal Express, and the internet to provide all this foundational capability that they could then add the value of Amazon and retail on top of. Well, the cloud does the exact same thing for space now. It's changed the way that startups and then our partners can move new capabilities and build things and innovate all the way up to the national security space world, and working with big commercial prime companies that everyone's familiar with. All of these companies now get to work and build on top of this foundation and innovate and do these great things. And on the large scale government side, the cloud specifically enables them to scale. It speeds everything up. It gives them velocity because it's very low latency, high-speed networking, lots of great services that allow them to not have to build everything over and over again. Mm-hmm. And then they also get the beauty of paying as you go, so that they don't have to have this big bow wave of funding to fund a mission critical system that is on all the time, and instead are only having to operate it when it's needed. And then this cloud provides this natural place to be interoperable and to integrate everybody from the small startups, commercial companies, big primes, and the government all into one framework and one infrastructure. So it really changes a lot about how everybody gets to work together as partners.
Yeah. Yeah, I really appreciate that setup because, as discussed, the purpose of this podcast series is to talk about how we can do more effective collaborative efforts to spark and accelerate innovation. And and it just sounds like from what you just said that having this cloud infrastructure and particularly having people build in order to operate in that space makes it much easier for people, different companies and different stakeholders to collaborate with one another.
Exactly.
Yeah. Okay. Well, I'm going to turn now to Jonathan. Because he's our resident U.S. Space Force expert. You've been working on focusing on integrating cloud into national security and space operations. What does a cloud native mission look like in actual practice?
Yeah, good question, Tamara. So I'll kind of start in the same vein that Shane started in, which is kind of where the space industry was, and then sort of highlight and take you on a journey into where it's going, specifically in a cloud native type way. So, I think for a long time, in the same sense that you had a small number of exquisite satellites, it was kind of the same concept on the ground side. So typically you'd have 1 to 2 operational centers that are running on premises hardware, right? And they're usually limited to a couple specific locations. And if you wanted to size that IT infrastructure in order to support your mission, a lot of times you'd have to put additional capacity into those environments, right? Where if something were to happen, you'd need to scale up quickly. And so what that meant is that a lot of times you would have, anywhere from, 30 to 70% of just idle capacity sitting there not being used for your system.
Mhm.
And in addition to that, you'd also have week-long software deployment cycles to update that hardware. You'd have to update that hardware every 3 to 5 years to keep up at the pace that the IT industry was changing. And you were also pretty limited, I think, geographically in terms of like where your operators could actually sit. And so really where cloud comes into the play is now you're not as limited from a global accessibility perspective, because now you can run a mission operations center in the cloud, and as long as folks have access to that environment, whether it's an unclassified or even classified environment, they could actually sit anywhere geographically and be able to operate their mission. One good example we like to use is, one of our partners one time wanted to highlight that they could task one of their synthetic aperture radar satellites at the dinner table at one of our events. So he pulled his phone and literally scheduled a collect for a satellite and had an image before the end of the dinner, right? So I think that global accessibility is really big. And then on the scale side, you with cloud, kind of the basic principles is that you only pay for what you use, right? Mm-hmm. So you don't have to really manage that unused capacity. And there's almost near real time, instantaneous, both vertical and horizontal scaling, right? So that allows you to be a lot more responsive to the mission needs, but it also significantly reduces the overhead costs. And then, from an operational perspective and kind of updating the software, using a common cloud platform really eliminates kind of those environmental differences between your development environment and your ops environment. So, I've worked on systems where we would update software once every 6 months, and it would take weeks and multiple people to go to an operational center and update that software. And now we've got a lot of these commercial customers, to Shane's point, with this low barrier of entry, you can take a software developer that's familiar in developing in the cloud and turn them into a space operations software developer, and they can push nightly updates or even instantaneous updates as that mission changes. So it really gives you a lot more agility in terms of being able to update that software. And then I think on the last piece I want to hit on this is really on the security and compliance piece. So some of these systems are pretty sensitive, and so as you start to bring in more third-party application providers and allow them to bring best-of-breed capabilities, you want to make sure that their software coming in is secure and works well, and that the operators are operating in a secure environment. And so really what cloud also brings is a lot of those built-in security controls and compliance frameworks. We are supporting a lot of the national security type missions as well, and making sure that we have that built-in security is critical for the mission, and be able to continuously monitor your software and have those automated security updates. I think in a lot of ways is actually as secure or even more secure of how we did it in the past. So I would say, as a closing point, cloud native missions really represent kind of a fundamental shift from those isolated hardware dependent operations to a much more flexible and scalable global space operations that can, at the end of the day, adapt to those evolving mission needs much better than how we did it in the past.
Yeah. Okay. So just taking into account that my role as executive director of SSPI does not include any technical awareness, very, very little technical knowledge. I'm going to ask it might be a very silly question, but it's the kind of thing that I think of, right? I just thought it was funny, interesting, exciting, and nerve-wracking to hear that that someone was decided to demonstrate at a gala that they could just download something from an existing satellite. Like, hey, I could just do it on my phone, and boom, and then it actually does happen. I mean, that is the shocking turn of events in terms of just the technological capacity that we've grown into as a society. We kind of expect that, and so it's not a surprise, except for that it kind of is, that applies even to our government systems and something as important as government satellites. And at the same time, I'm like, wait, what? I don't know how to feel about that. I'm like, that makes me very nervous to think about the ease of access in possibly unsecured locations to content. And it also makes me think about just the fact that something that's in the cloud is not on a proprietary piece of hardware. And I hear what you're saying about it being secure, but how do you get there? How do you get to making sure that the systems themselves, the systems of access, are secure enough that this profound agility isn't itself a liability?
Yeah, it's a great question, and I definitely want Concha to chime in on this, but not every mission is created equally, right? So we support a lot of commercial space companies out there that aren't collecting necessarily what you would consider classified information. That might be doing things like doing disaster relief, floodplain monitoring, right? Being able to respond rapidly to spreading wildfire. And so there are significant amounts of use cases out there that aren't really national security focused. So, one of the things that you can do actually, if you're a hobbyist, you can actually put a ground antenna out there and actually collect downlink information from NOAA satellites that are flying around the world, and actually get images off of those, right? So I think a lot of folks would suspect that it's really hard to be able to capture a downlinking information off of satellites, but this is something that's been going on for decades, depending on the mission, right? So if you're taking pictures to monitor weather, depending on where you're at in the world, right, a lot of that can be unclassified. But on the security side of the house, right, like AWS, really what we are focused on is ensuring both that data at rest and that data in transit is secure. And so we built in a lot of great capabilities surrounding encryption over our networks. The way that we pass data through those networks is done in a secure way to ensure that data in transit is encrypted so that only the right person, right operator, right user can actually access those systems to do things like task those satellites, right? So he might be accessing it on his phone, but what's going on in the background is all those security controls are validating that it truly is this person that has these specific user permissions that are able to actually access the software and conduct the operation that this person is only allowed to do, right? And so that's a big thing with us with the shared responsibility model. You know, we're responsible for ensuring that the cloud in itself is secure, but at the end of the day, there is also a responsibility of our partners and customers to ensure that how they architect their system within the cloud is also secure, and that's where people like Akanksha are great solutions architects within AWS that can advise you on what makes a system more secure and making sure that security is built in to make sure at the end of the day you don't have the wrong actors accessing these systems to potentially do nefarious things on them.
Yeah. Thanks. Akanksha, do you want to weigh in on that a little bit?
I think Jonathan covered that perfectly. You know, at AWS, the way that we describe security is exactly like you said, the shared responsibility model. So we do have security built in to what we call a lot of our managed services. And also, you know, if you can kind of go up the stack in terms of being as managed as you want, where we're providing a lot of the capabilities that are essentially built on top of the core pieces that we provide at AWS, which is our compute. And so we try to build in some security best practices into our services and also give our customers who are building on AWS the abilities to turn different knobs to make sure everything is secure to the degree that they need their data to be. So we do support data that requires security levels of great degree. And so we do have the methodologies in place to enable that, but we work very closely with our customers to ensure it's exactly what they're needing for their mission and for their data.
Mm-hmm.
And you know, Tamara, this is Shane. I thought it would just be cool to make sure the audience knows as well that the example that Jonathan gave of the dinner party satellite tasking, that even shows the ability of AWS, because that was just a small startup. That wasn't even a government satellite, and they still were able to access the security Jonathan talked about and enable that kind of a really impressive capability for even a smaller startup company. So it's really cool.
Yeah, that is. Listen, it's phenomenal. It's just one of those things where you say, wow, have we gotten that far? And it's so impressive that AWS is enabling that level of progress. And like you say, Shane, that label of access, especially for smaller companies that need to be able to punch above their weight in order to succeed. So thank you for calling that out. That's very important. I want to go back to Akanksha, because Akanksha, you're doing something interesting. It's all the buzz, this whole issue of AI across the board. AI is interesting and scary and all the things, but it's also really a big deal of transformation currently in our industry. So you're working right in that space. What does it mean to make these systems intelligent? And what kinds of breakthroughs are you excited about? And what kind of breakthroughs are we seeing here at AWS?
Yeah, no, I think when I'm thinking of intelligent systems, I'm thinking of systems that are being augmented by artificial intelligence, machine learning. And ultimately, what these systems are aiming to do are enhancing that human experience for the end users in mind. So what that could mean is reducing the amount of time that it's taking, or perhaps increasing the accuracy of a previously very manual or repetitive task.
Mm-hmm.
And so some examples of how we're seeing this in the space industry could be automated object detection from your imagery that's coming in. So you have satellites doing collects of some imagery, you have a model plugged in that's able to detect airplanes, classify weapons, identify buildings, things of that nature. Other use cases could be predictive analysis, predicting where a vehicle might be in X amount of hours in the future based on the terrain or historical patterns. And more commonly now with generative AI, we're seeing a lot with text data. So aggregating information across sources from the internet, your documents, specific data stores in order to answer a user question. And so what I'm particularly excited about is taking these intelligent systems and doing a little more with intelligent automation. And with the advent of AI agents, and so think of, the traditional LLM as giving you suggestions. Agents are taking it a step further with the LLM now being able to take actions against specific tools. So retrieving relevant documentation based on a user question, maybe plugging into different functions, APIs, plugging into your existing systems, or maybe even querying some of your existing data stores. So think your databases, your open search clusters. So the agent has an understanding based on a question that I'm asking in natural language, how to turn that into an action it takes against one of these tools. An example I like to provide is I'm asking about cost in my AWS account. The agent plugged in understands it needs to make maybe a function call, the get cost function with a conscious account ID plugged in, the date she's looking for, etc. So it is super cool to see this paradigm emerge where we think of automation as robotic process automation, that step A needs to happen, then B, then C, and always in that order.
Mm-hmm.
And if anything messes up, the entire workflow is interrupted.
Mm-hmm.
But now with this intelligent automation concept that we're seeing, you can pick and choose based on the user question coming in. Maybe you just do step B, or then you do B, C, and then A. And so the agent is able to facilitate that and lend itself to more workflows and do some of that error handling up front. Yeah. So we're seeing a lot with agents, multi-agents, agent swarms, and I'm super excited to see how it's going to change the paradigm literally in our space.
You are listening to The Better Satellite World, the longest running continuous podcast in the commercial space and satellite industry. The Better Satellite World podcast is funded by the corporate partners of SSPI, Hughes, Access Intelligence, the American Space Exploration Fund, and Qvia. Have you heard about SBQ? Space Business Qualified is a popular online learning program for industry professionals designed by GSOA, SSPI, and SatProf. To learn more, visit spacebq.org. In September and November, join SSPI and the New York Space Alliance for the next New York Space Business Roundtable. If you want to get inside the industry's biggest issues and investments, meet startups and high-profile industry leaders from around the world, the Roundtable is a real New York event you cannot miss. You can now register for our next New York Space Business Roundtable, which will be on September 30th. Call or raise Europe Bets on Sovereign Space. To register for this upcoming roundtable, visit sspi.org/events. And now back to the Better Satellite World.
I hate to use the phrase, it's so cliche, but really it does feel like a brave new world, right? It's just so dramatically different, the impact that artificial intelligence and artificial intelligence systems are having in basically every walk of life. And space is no different. And while you were describing that, I guess I went through a couple of questions. You mentioned about retrieval, augmented generation. I guess that's the language. Mm-hmm. And you were talking about just how you can get uh, the artificial intelligence, the agent, to actually make actions on behalf of the user because of the correct inputs. And I think that's phenomenal. And I would hire an agent in a heartbeat if I could. So many workflows that I'd love to be able to have someone else do. But when we're talking about space, and the humongous range of data that you have to work with, in order to make a mission succeed, obviously this kind of technology and this kind of capability is genuinely transformative. How do you prove this system? How do you prove that you know that there was not a failure either at the user input side or some other step along the way?
Yeah, no, that's a great question. And that's something that we're always trying to work with our customers on as well. Because you can take any workflow, whether we're talking about that classic AI ML standard machine learning workflow or a Gen AI workflow, and the questions are kind of the same of how do I make sure my models are operating the same way in production as they were during testing, taking human feedback, all these questions. So that becomes even broader of a question to enabling good ML ops practices. So the first thing that we usually talk about with our customers is, to your point, what sort of data is important for this workflow? Do you have the right data strategy in place? What I mean by that is your data co-located or organized in a way where there's easy access for your models to either train on or to run inference on? And then from there, do you have mechanisms to see how your model is doing in production, right? So you're working with these agent workflows, for example. Does it have access to the right tools from across these different systems, the right database, the right applications, right? Because if we're thinking about a satellite operator, their job is making sense of a lot of data very quickly. And what we've noticed is that they're working across many different systems. So they're hopping from system A, maybe pulling down information about available satellites from a database, hop into system B, then using another API to track it in real time. So you want to make components of these systems now available to these agents, to these models to maybe facilitate orchestration across. So that's usually another step that we tell our customers to start thinking about, or what are the tools that you want the models to leverage? And then lastly, do you have a mechanism for that human in the loop aspect? And that's a huge key term that we're hearing in the industry is, do you have the right validators at the end of the day that can monitor and essentially give you thumbs up, thumbs down of human performance? And that can ultimately feed back to the model and make sure that the next time the model is running, it has an understanding of the human preferences or where I messed up so that next time I don't do that kind of behavior.
Yeah.
So it's a very comprehensive process altogether, but it's something that we do hear about a lot and we help our customers with.
Yeah, you were talking about the workflow, and I was just thinking, yeah, it seems like, I mean, super basic, right? I mean, I've fallen in love with these AI note takers. I mean, it makes my world so much easier. And yet there was an obvious system fail, right? Because if I'm in a Zoom meeting that you had to be registered for, well, the AI note taker can't register itself. So it can't get into the meeting. And so it's just one of those things where, like you say, does the agent have access to get into the systems that it needs to enable to perform? And is that an opportunity, right? Is that an opportunity for a human to kind of pause and say, okay, let's check where we are in the data flow, and then hit yes, the agent may go forward. Is that an opportunity, or is that the kind of work that happens, or is that just me making things up?
No, that's exactly right. When we're thinking about agent workflows too, maybe before an agent is taking an action, you want the human to be cued in, right? Because sometimes for these systems that we're designing these applications for, right, this has national security mission context in mind. So sometimes these systems are doing collection across different data sources, and it's giving a suggestion to the human of, hey, maybe I should take this sort of action. Or before I go task a satellite, one of the recent agent workflows we've done is providing to the satellite operator of, hey, based on these different systems, I can tell that this satellite might be the best for a viewing location for this place in this amount of in the next 6 hours. So which satellite has best visibility of New York in the next 6 hours kind of thing. So before you want a satellite maybe to go and task, or the agent to go and task a satellite, you want that human to be plugged in and give the thumbs up before an agent or a model goes and executes. So it's definitely a common pattern that we see.
Yeah. Wow. I mean, you guys are just kind of, I'm having a mind-blown experience here because there's just so much acceleration of technology and capability in what you're describing, and it's very exciting.
You can see why I brought Akanksha and Jonathan along, right, Tamara?
Absolutely, absolutely, and thank you for that. Well, let's go back to this idea of partnerships and collaborations, right? So we've always our industry has always had a collaborative and critical role in delivering to the government customer, and that's frequently where we get an impetus for acceleration of development. The government has very big needs, and they're willing to pay for those capabilities. As you've been working with, say, for instance, Space Force or even other commercial partners, what have you been learning about partnership, and what makes them succeed, and what makes them challenging? And that's to all of you.
Yeah, well, if you don't mind, I'll take the first crack at it, and then I'll cede the floor to Jonathan and Akanksha. What we've really learned is it's interesting if you look at the overall space mission area, and it's always been a partnership-driven area. We've had people that built the space vehicles. We had other companies would come in and build the launch vehicles. You'd have a launch services integrator working in between them to get them onto the top of the rocket. And then once you launched, you would even have another company building the ground segment or operating a satellite. So space has actually always been quite collaborative if you think about it. But the partners and the working together with AWS to build space systems together has even shown that you get even better acceleration from at least a couple of lessons that I've learned. One would be that what really works well is many times startup companies or new ideas will be kind of protective, and they try to protect everything and their intellectual property. And that's totally understandable. But I would just say, trust your NDAs, trust the teams that you're putting together, and be completely open and work together, because Amazon likes to obsess over the customer and meeting their requirements. And so the more we know about what you're trying to do and what you're building, the more that we can help you actually make it most efficient on the cloud, fastest, and require the least amount of resources on the customer side to operate and continue. So that really works well, is to be open, share your requirements, and let it all hang out so that Amazon Web Services can help you get to where you want to go. What I've noticed doesn't work is, in the old days of space, again, we would be very almost risk averse. We would be very step by step, do every single thing perfectly, don't allow anything to fail, move to the next step. And that can really drive cost, and it can really result in a very slow development cycle. It's much better to be bold, to proceed and take risks, be willing to fail fast, and move out in a much quicker way. You'll learn more. You'll get a system that meets your needs, and it'll typically be more cost effective because it'll happen much faster. What are some of the things you've seen, Jonathan?
Yeah, I think one of the interesting trends that we've seen from a collaboration perspective is kind of seeing the same sort of model of how software really transformed in the 21st century to start doing more microservice-based architectures where you're able to bring in SaaS products that really are providing that best of breed. And you're kind of seeing that both on the ground and space side in both software and hardware. And so, as they start to standardize some more of these interfaces, specifically on the hardware side with the satellites, with things like Ethernet, IP networking, and on the software side, leveraging more APIs and cloud native architectures. What that allows folks to do is really to go out and build a system that's really bringing in the best of the best for each one of those niche capabilities, whether it might be a payload on the satellite or a reaction wheel or a solar array. And in the same way, on the ground, you might have a company that builds an amazing data processing algorithm, and being able to bring all of those different partners together and get those solutions to collaborate with each other to deliver not only a better system as a whole, but also to allow other companies that might just want to be an expert in one field to be a part of the overall space ecosystem, rather than kind of having those siloed. I'll build the satellite, you build the rocket, and there's only two of us, right? Now you're looking at dozens of potential companies that could collaborate on a single mission, which I think is very exciting for us. And AWS is trying to build that ecosystem from a cloud perspective, to create environments, to do model-based systems engineering, to connect those pieces together, and then also provide that software environment to connect all those various pieces of software or SaaS into an end-to-end solution for command and control and data processing.
Well, I'm a little stunned at the idea of dozens of collaborators on a project, and yet it makes so much sense, right? And Shane, to your point, yeah, I mean, it's the biggest headache that you ever hear of about government contract cost overruns, and that it's because the specifications are really particular and everybody has to get it right, and there's multiple players who also have to all get it right, and then it all has to fit together. And so it's exciting that you're creating an ecosystem where that can work more efficiently. I completely agree with the idea of getting it wrong to learn. I'm a big advocate of this because, we know that it is actually rocket science. It's hard. It's actually hard. And so we have systems, you're building an infrastructure where that kind of experimentation can go effectively and efficiently and fast, so that we can have a successful outcome. I want to turn to Akanksha, and I'm talking about ecosystems, and you guys are been talking about collaboration and the infrastructure to collaborate. From your perspective, how is the role of space overall shifting in the broader technology ecosystem? And do you find that it's still operating as a silo, or is it becoming something much larger?
Yeah, as someone who's been working in now the space industry, and specifically systems and AI ML applications geared towards space, we've learned as solutions architects a lot of patterns and best practices to deal with the unique things related to space. So what I mean by that is oftentimes we're working in our DDoS environment. And so what we mean by that is that denied, intermittent, you don't always have connectivity to the cloud. It's intermittent and limited. And so obviously when you're building systems that need to be resilient and running, having that sort of environment, limited connectivity proves to be a little difficult. So how do you build for that? So that has taught us a lot of lessons that we take from building these space systems of how do you ensure there's no data loss if there's a loss of connectivity? What happens when there's a system failure? How do you recover quickly from that? I, as a solutions architect, have taken my practices that I've learned with working with my customers in the space industry, and I've brought it back to the broader AWS cloud space where other solutions architects are working with different types of customers. And it's enhanced their overall resiliency posture of their systems. Another example, I know you mentioned this earlier, is just the amount of data that we have to process that's coming in and streaming in from many different satellites, many different sensors. So how do we process that at scale? How do we build these hybrid-based applications, these systems? How do you do things on the edge, data processing on the edge, machine learning at the edge? So a lot of those best practices as well for hybrid and data processing, quantized models running on limited hardware. How can I bring those practices now to the broader audience? Because these are some of the challenges that they're facing too. And now the lessons learned that I've learned from working with my customers in this industry, I'm directly taking that and applying it and leveraging and writing white papers about how to bring that to the broader AWS cloud community.
Okay, I may need to see some of those white papers, Akanksha.
And I think it's a changing paradigm, right? Because you mentioned that we might be operating in a silo, but I think now as we're operating, there's this bi-directional flow of information both ways.
Well, I am just going to say this again. I said it earlier in the interview, and I'm gonna say it again. You guys are really leading a dramatic shift in the way we think about our industry, the way that we work within our industry. And I'm very excited to have had this opportunity to talk to you about how a cloud-based structure can set an infrastructure platform that allows us to be more collaborative and effective and agile. And so congratulations to all of you for the work that you're doing and will do. And I think that's where I'm going to leave it. Unless anybody has anything burning desire to say one last thing, I'll open up the floor for that.
I just wanted to say, Tamara, to thank you to you and to the Space and Satellite Professionals International and to SES for having us on this podcast. We really appreciate the chance to share the things that we love doing here at Amazon Web Services with our space customers.
Absolutely. And thank you so much for being here. And with that concludes today's episode, Digital Speed, Cloud Native Operations, and the New Space Architecture. We thank our guests, Shane Hawthorne, Jonathan Fraker, and Akanksha Alak, for sharing their insights with us. This podcast is made possible by the support of SSPI's professional, student, and corporate members. We are especially grateful for our corporate partners, Access Intelligence, the producers of Via Satellite Magazine, the American Space Exploration Fund, formerly known as the Space Shuttle Children's Trust Fund, the law firm of Clyde & Company, Hughes and EchoStar Company, and our newest corporate partner, Qvia, who we'll hear from later in this series. To learn more about SSPI, visit sspi.org and follow us on X, at SSPI, LinkedIn, Instagram, and Facebook. New episodes of this podcast, including the Better Satellite World podcast, the Satellite Futures podcast, and She Reaches Women in Space, are released every Monday. Subscribe at sspi.org/SSPI-podcast. Subscribe on Spotify, Apple Podcasts, iHeartRadio, or wherever you get your podcasts. And our newest feature, you can subscribe to all of our podcasts on YouTube at SSPI Video, all one word. For SSPI and our producer, Ari Yates, I'm Tamara Bond-Williams. And for the people and companies building a space and satellite future worthy of our highest aspirations, thank you for all you do.